12 half steps was created, it actually originated in Greece. I mean, pretty much everything has originated in Greece. But basically the person who created this concept, his name was Pythagoras. To middle schoolers, he is the guy who is on their math exams. To parents, Pythagoras, and to admin, I have no idea. So what we will first examine is how this scale is different from the others. And so first of all, this is mainly used for pianos, and so there's actually still 12 steps. And Pythagoras thought, well, I want a simple scale, and so I can simplify it, even though there's slight errors, and some music aficionados like precision and don't really like this scale. This is what we use, as it is easier, and we don't have to retune our instruments every single time as we did before. And so we start with 440 hertz at the A, and now we become we can measure 12 steps all the way to the octave A, which is actually twice the frequency. So you can see that every step, as we said, it's going to have the same ratio, which is approximation. So it's going to multiply the frequency by the same factor. And so therefore you're going to multiply 440 hertz 12 times, and you're going to get 440 hertz times r to the 12 equals 880 hertz. And then you'll actually determine r equals 5.95%. What does this all mean? Basically, the frequency will, every time it goes up one note, for example, from A to A sharp, it will increase by 5.95%. If you don't learn anything else from this presentation, just remember 5.95%. Now, I will actually go into the physics of this, which will make my physics teacher proud. Right now, so we have speed equals lambda times f, and this equation actually is derived from harmonics and equation. And so this is speed, and lambda actually signifies the wavelength, which is basically how much the length of the wave travels through, and the frequency is basically how many waves per second there are. So if you can imagine just intuitively, you can see that when you, for example, if there was a rope between me and Nick, we couldn't get the rope. We could actually, whenever you try to basically swing the rope faster, you can assume that, well, the wave would actually get shorter. And that actually intuitively explains the inverse proportionality between the wavelength and the frequency. And so basically, as explained by the middle school orchestra, whenever you press on the string, it creates a note, therefore making sure that the string does not vibrate at that point. And therefore, when you shorten the wavelength, it increases the frequency. And so this is a wave diagram, and for those of you in the back who could not see it, we're very sorry. You should have come more into the front. So basically, you have 440 hertz, and at the A, basically, as said before, because of this ratio, 2 to 1, whenever you press on the middle, then it actually decreases the wavelength by 2, and therefore the frequency increases by a factor of 2. And so this can be said for the notes. And for harmonics, it's a different story, because it's different because when you compare it to just pressing on the string, harmonics is when you're touching the string. So if the orchestra could just please play the last few measures of our previous song.